There is a weapon small enough to fit inside a van, small enough that you could drive it into a city, park it on a street, and walk away. And it carries enough energy to kill tens of thousands of people in under 10 seconds. This is the simulation of a 15-kiloton nuclear detonation in a major city, the same yield as the bomb dropped on Hiroshima in 1945. Every effect you will hear about is drawn from verified scientific data, US government weapons effect studies, and peer-reviewed research. We are not simulating a hypothetical weapon. We are simulating one of the smallest nuclear devices ever used in warfare and showing you exactly what it does. The weapon detonates at approximately 580 meters above the city center. This is not an accident. That altitude is deliberate. Physics established long ago that detonating a nuclear weapon above its target, rather than on the ground, maximizes the area of destruction. When the blast wave travels downward and reflects off the ground, the two waves merge into a single, more powerful shock wave called a Mach stem. It travels outward at the surface level, hitting every structure in its path simultaneously. The bomb dropped on Hiroshima was set off at 580 meters above the city. The entire reasoning for that detonation height was to maximize blast and fire effects. The science has not changed. An airburst at this altitude for this yield is the most destructive configuration possible. In the first millisecond, nothing visible happens. Then the fireball forms. A nuclear weapon detonation produces a massive pulse of X-rays that heat the surrounding air to extreme temperatures within less than 1/1,000,000th of a second. Inside the fireball, temperatures reach tens of millions of degrees, comparable to the interior of the sun. At these temperatures, molecules and atoms are completely disintegrated. The fireball expands to its maximum size in roughly 10 seconds. Anyone within its radius does not burn. They are gone before they can register what is happening. Now the effects move outward in rings, and this is where the physics becomes something you have to sit with. Within roughly 1 mile of ground zero, what scientists call the severe damage zone, almost no buildings are left standing. Reinforced concrete structures are heavily damaged. Multi-story buildings collapse. The overpressure, the sudden, violent compression of the air, exceeds levels that crush human bodies, whether indoors or out. The Hiroshima bomb created total destruction within 1 mile, severe damage out to 2 miles, and caused burns at distances up to 3 miles from ground zero. The thermal pulse, the intense flash of heat that travels at the speed of light, arrives before the blast wave. Anyone in the open within roughly 2 kilometers who looks toward the detonation risks permanent blindness from flash burn to the retina, even at distances far beyond the destruction zone. A 3-second thermal pulse from the blast burned the exposed skin of people as far as 3.5 kilometers from ground zero and started fires throughout the city. The blast wave follows seconds later. By this point, the fires have already begun. Within 20 minutes of detonation, the individual fires merge. At Hiroshima, a mass fire, a conflagration, developed approximately 20 minutes after the explosion and ultimately consumed essentially all combustible material within a radius of about 2 kilometers. This is the part that is often left out of simplified descriptions of nuclear weapons. The blast does not kill most people. The fire does. The heat, the oxygen displacement. The toxic gases from burning buildings, survivors of the initial blast who are trapped under rubble, are killed by the firestorm that follows. It is estimated that roughly 60% of deaths at Hiroshima were caused by burns, 16% by the blast itself, and 7% by radiation. The city does not explode, it burns. Now we come to radiation, the effect people most associate with nuclear weapons, though, as the data shows, it is not the primary killer in the immediate event. There are 2 phases. The first is prompt radiation, the burst of gamma rays, and neutrons released in the first minute of detonation. Most people located within 1.5 kilometers of the hypocenter were killed by the combined heat and radiation blast, with very little shielding provided by buildings. Beyond that radius, prompt radiation causes acute radiation syndrome, a systematic breakdown of the body's ability to produce blood cells, beginning within hours and progressing over days and weeks. The second phase is fallout. Because this is an airburst detonated high above the ground, the fireball does not touch the surface. It does not suck up soil and irradiate it the way a ground burst would. The resulting firestorm carried fission products into the upper atmosphere. and the fallout was spread over a wide area rather than concentrated locally. This means fallout is a serious but manageable threat for people outside the immediate blast zone if they take shelter quickly, and stay sheltered. We will come back to that. Let's talk about what the numbers actually mean. The Radiation Effects Research Foundation estimates that Hiroshima had a population of 340,000 to 350,000 at the time of the bombing, of which between 90,000 and 166,000 had died by the end of that year. A modern city denser, with more high-rise buildings that both concentrate and sometimes shield populations, would produce different numbers. But the order of magnitude remains the same. Tens of thousands dead within seconds, tens of thousands more within days, and then the slower deaths, the ones that take years. 5 to 6 years after the bombings, the incidence of leukemia increased noticeably among survivors. After about a decade, survivors began experiencing thyroid, breast, lung, and other cancers at higher than normal rates, and radiation-related cancers continued to increase throughout survivors' lifespans. The weapon kills in waves. The first wave takes seconds. The last wave takes decades. There is something else that does not appear on blast radius maps. The collapse of medical care. All the dedicated burn beds in the world would be insufficient to care for the survivors of a single nuclear bomb on any city. This is not rhetoric. It is a logistics reality. A 15-kiloton detonation produces more severe burn casualties in a single moment than the entire global capacity of specialized burn treatment can handle. Hospitals within the blast zone are destroyed. Hospitals outside it are immediately overwhelmed. Medical personnel who rush toward the impact zone without protection become casualties themselves. In Hiroshima, most victims died without any care to ease their suffering. That was 1945. The medical arithmetic has not improved enough to change the outcome. Now, what can a person actually do? The answer, grounded in FEMA guidance and decades of civil defense research, is more than most people think. The single most important action, if you are outside the immediate destruction zone, is to get inside a solid building, move to its interior, and stay there for at least 24 hours. Fallout radiation decays rapidly. The rule used by emergency planners is the 7-10 rule. For every 7-fold increase in time after the explosion, radiation levels decrease by a factor of 10. Radiation that is lethal at 1 hour after detonation is drastically reduced by 7 hours. By 48 hours, it has dropped to a fraction of its initial level. The people who survive a nuclear detonation at moderate distances are not the ones who run. They are the ones who shelter in place, stay informed, and do not go outside until authorities confirm it is safe. Distance and shielding. Those two words account for most of the difference between life and death outside the immediate blast zone. We end where we began. A weapon small enough to fit in a van. The Hiroshima bomb used about 64 kilograms of highly enriched uranium and had a yield of 15 kilotons, equivalent to 15,000 tons of TNT. It destroyed approximately 90% of the city. That yield, by the standards of today's nuclear arsenals, is considered small. Most modern strategic warheads are 10 to 100 times more powerful. There are roughly 12,000 nuclear warheads in existence today across 9 countries. This simulation is not about fear. Fear without understanding is useless. It is about physics, about what energy at this scale actually does to buildings, to bodies, to a city's ability to function, to a population's ability to survive. Because the most dangerous thing about nuclear weapons is not the blast radius, it is the assumption that their effects are too extreme to think clearly about. They are not. The science is precise, the data exists, and understanding it, even in the worst case, is the first step toward making sure the worst case stays exactly that, a simulation.